All right, you guys, today is easier day, I would say, than yesterday. You'll notice in the assignment, we actually have a worksheet today as well, and that's just kind of a little review and practice on stating domains from yesterday's lesson, okay? Because today is pretty straightforward, and the assignment honestly shouldn't take you very long at all. So we're looking at inverse functions and relations today. So finding inverses, okay? Really rocket science. I'm gonna have you look right now at set A. So this is function A or relation A, and this is relation B. I'll give you a few seconds to look at those and compare the two. I will tell you A and B are inverses of each other. Oh my gosh, you guys are so smart. So you take your points, and to find an inverse, you switch them. Oh man, crazy hard, right? Crazy hard, okay? So to find the inverse of a relation, we're switching our x and y coordinates. If we have a function instead, an equation, what do you suppose we do with our x and y coordinates? We would switch those as well, okay? So kind of taking a peek at example one, it says find the inverse of a relation. The vertices of triangle ABC can be represented by 2, 4, 1, 3, 4, -1. It says find the inverse of this relation. Well, to find the inverse, what do? We switch the x and y coordinates. No way. Really? Yep. That's as hard as it gets. Okay? Most confusing part of the day is going to be notation. Okay? You are very familiar with f of x. When we're talking about function notation, it's always going to be denoted as f to the -1 of x. F to the -1 is basically stating that you have the inverse of function f. Okay? And that's probably, the most confusing part of the day is just that notation piece. All right? So in this case, it says find the inverse. All right? So we're going to graph the function, and its inverse is the inverse of function. So we're going to find the inverse, and notice this is a function to start. Okay? So remember back to, middle school. Can't remember which grade, if it was 6th, 7th, or 8th grade. But you talked about this vertical line test. So we know that 2x plus 3 passes our vertical line test. And I mean, okay. So it says find the inverse. All right. So what I'm going to do is I'm going to find the inverse. Remember, f of x is just y. How do I find an inverse? I switch them. So I'm going to say x equals 2y plus 3. And then I'm going to get y by itself. So we wind up with y is 1/2 x minus 3/2. All right. So minus 3/2 is minus 1.5. And then we go up 1 over 2, down 1 over 2. All right. So we just graphed our original function and its inverse. Hopefully that piece kind of makes sense. Is the inverse a function? Well, does our line in green pass the vertical line test? Why, yes, it does. All right. So both these are functions, our domains, all reals on both of them. We're good to go. All right. Looking at this next one, it is a function. Okay. So we're just going to graph this x squared plus 2. Okay. So we just graph that. We want to find its inverse. All right. So we're going to switch our x and y. We wind up with x equals y squared plus 2. All right. At this stage, we'd like to get y by itself to make it easier to graph. So we subtract 2 from both sides. And we have y squared. Then we need to square root both sides. So we get y is plus or minus square root of x minus 2. All right. So the question is, how do we graph this? Well, all right. We haven't graphed this yet, but if you remember from before, we can just switch our x and y coordinates around. So if I have 0, 2, I should have 2, 0. If I have 1, 3, I should have 3, 1. If I have negative 1, 3, I should have 3, negative 1. Okay. So again, if you don't know how to graph something, just grab a few of your coordinates and flip those x and y's. All right. The last piece of this is the inverse of function. Well, looking at the green graph we just drew, I can tell you it is not a function right now. Okay? No, not a function. Fails the vertical line test. So the question is, how could I now make this a function? Okay? Well, remember talking before or yesterday about our domain restrictions, I now have an even root radical. Okay? So what I could do to this problem to make the inverse a function is I could restrict my domain. Okay? If I restrict the domain and just say x has to be positive values greater than or equal to 0, then that piece of my graph goes away. Is what's left a function? Yes. So I could restrict my domain. Then I would have my inverse function, which is square root of x minus 2, and the domain would have to be x is greater than or equal to, whoops, not 2, greater than or equal to 2, what I meant to put, okay? So now if I restrict the domain, now that second piece is an inverse function, I'm good to go, okay? So that's kind of the big idea with things. So if you're ever asked, you know, is something an inverse function, or how could I make sure that an inverse function exists? Well, you just need to restrict the domain so that it passes the vertical line test in both situations, all right? And this is kind of something we talked about, or sorry, not we talked about, we addressed the vertical line test, but the horizontal line test is used to figure out if the inverse is a function, okay? So if we think about this, this is a graph of maybe something like, you know, negative x cubed. All right, does it pass the horizontal line test? Yes. So the inverse of a cubic function does exist. All right, where we have something like this, this is a fourth degree function. Remember, if it, sorry, getting my thoughts together. So you have a fourth degree function. So when you switch these and then take the fourth root, what ends up happening is you have to restrict your domain in order for this function to exist because it fails the horizontal line test. And we kind of talked about that yesterday. Whenever we have even root radicals, that's a problem with our domain. Just like if we have a fourth degree polynomial, the inverse is not a function unless I were to restrict that domain. Okay, so the horizontal line test is used to determine if the inverse of what you see is a function, okay? And that could be used back here. If I look at my blue graph, this fails the horizontal line test, which means the inverse was not a function, which we found, which is why we restricted the domain, so the inverse was now a function. All right, verifying inverses, you must use compositions, okay? Compositions. Okay. This is going to be worth multiple points on the quiz. Do not just switch X and Y and go with it. All right. In order to verify functions are inverses, you must use function compositions. So you have to do f of g of x. You have to do g of f of x. And the eventual goal is to show me, sorry, my writing got away from me there. You want to prove that f of g of x equals x, and you want to prove that g of f of x is x. I said the bad word, I said the p word. All right. So what we do is we take f, and we're gonna plug in g, and we're gonna simplify. So we distribute, we wind up with x minus 9 plus 9, which is x. That's a good thing. We're gonna take g, we're gonna plug in f. So we distribute, we wind up with x plus 3 minus 3, which equals x. In this case, yes, they are inverses. All right. Again, you have to do compositions. Do not switch the x and y to show me one equals the other. Okay. And I'm not kidding about this. On your quiz, if you just switch the x and the y and show me they're equal, you're not getting points on the problem. To verify inverses, you must use function compositions. Okay. So we'll do f of g. So we have 4x squared. So I'm going to take 2 root x, plug it in. I wind up with 16, right? Because that's going to be 4x. So I wind up with 16x. Do I even need to check the other one? No, because that was not x, right? So again, today, lots of verifying inverses, should go pretty quickly as far as things go. And then we are throwing in that review sheet from yesterday just to go over some domain topics. If you have questions, let me know. Otherwise, get your stuff done and enjoy your weekend.